Now we come to the session 20. The, we already know some theorems, theorems on integrals and properties of a line integral, path integral, some basic properties of a line integrals. Now, yeah, we'll solve some few problems regarding using definitions and basic properties of line path integrations. Line and path integrations. In See, we are integrations, we know the properties. Suppose if we take an x by axis, if I take a line, so I take a PQ line, we divide a number of subinterval form. I call the subinterval P1 of Z1, P2 of Z2, etc. Where Z1 and Z2 are these are all complex form, complex numbers. Say, consider a continuous function f of z of a complex variable z equal to x plus iy defined at all point of the curve C. So we take a curve PQ. I denote this PQ then a curve C. Extending from P to Q, divide the curve C into n part by arbitrary taking a point. So denote this P equal P of Z1, P1 of Z1, P2 of Z2, Pk of Zk, etc. Pn of Zn equal to Q on a curve C. Let alpha k be any point on the curve, alpha k be any point on the arc of the curve from pk minus 1 to pk minus 1 to pk. So we take a very length of that should be delta zk is equal to zk minus zk minus 1. So the length should be, we are taking that length. Let I call delta zk is equal to zk minus zk minus 1, where k equal to 1, 2, 3, etc. So then take a limit n tends to infinity summation of f of alpha k delta zk. So k varies from 1 to n, where maximum of absolute values of delta k tends to 0 as n tends to infinity, defined as the complex line integral along the path C, usually denoted by integral of f of z dz of a curve C. Integral of C f of z dz. We denote that. See, suppose the line integral is a path integral. If I denote a path, if it denotes a C, length PQ, we divide number of subinterval P1 of Z1, P2 of Z2, etc., Pk of Zk, and etc., Pn of Zn, where Z1, Z2, etc. is a complex number. It's a complex form. So we take it alpha k. That alpha k be the difference of pk minus 1 to pk. Simply say absolute delta zk should be zk minus zk minus 1. So if we take distance relax, so if we take a limit, sum of this limit n tends to infinity, summation k varies from 1 to n, f alpha k delta zk, where maximum of absolute values of zk tends to 0 as n tends to infinity, defined as a complex line. We denote this integral, so integral of C f of z dz. See, we all know the properties. So basic, again I say, if minus a is denote reverse, suppose if we take, so integral of p to q as a path is taking p to q. Suppose reverse, if we take q to p, the say if minus c denote the curve reverse from q to p, that is, we say integral of minus c f of z dz should be equal to minus sign of f of z dz. Secondly, integral of c, the path c as a f of z dz should be equal to integral of c1 f of z dz plus integral of c2 f of z dz plus integral of c3 f of z dz, etc. So divide number of subinterval, each path should be c1, c2, c3, etc. So where c is split into number of parts c1, c2, c3, etc. If you take a and b be any constant, let a and b be any constant, or if a and b are constant, then integral of part c a f1 of z dz plus or minus b integral of integral of c a f1 of z plus b f2 of z of dz should be equal to a times of integral of c f1 of z plus or minus b integral of f2 of z dz f dz. So this is the property. If we take a line integral on a complex valued functions, is generally line integral similarly same in the form of a real integral. See, here we want to integrate first separate real and imaginary terms, then easy for substitutions and integral. So if you take here given, let f of z equal to u of x comma y plus items of v of x1. Let f of z equal to u of x comma y plus items of v of x1 be complex valued function defined over region R and C be a curve in a region, then integral of c f of z dz is equal to integral of c u plus iv dx plus I dy. So substituting the z is a complex number u plus iv, then dz become dx plus I dy. So again I am separating real and imaginary parts. So I hope on this that u dx, again I square become minus 1 minus v dy. So actually this is v u dx minus v dy plus I times of integral of c, again I times of u dy again plus v dx. This is the term. This shows that evaluation of a line integral of a complex valued function is nothing but the evaluation of a line integral of a real valued functions. This is the difference. What's a real valued? What's a complex valued functions? This is the evaluations. If we take some few example regarding the same properties of a complex integrals. So take an example. Integral of z square dz of c. First one, along this right line from z equal to 0 to z equal to 3 plus I. Second one, along the curve made of two line segments, one from z equal to 0 to z equal to 3 and another from z equal to 3 to z equal to 3 plus I. See, this is the values. First, we take along a straight line from z equal to 0 to z equal to 3 plus I. Now, a given problem, so integral of z square dz. So, first, along a line z equal to 0 to 3 plus I. So, integral of z equal to 0 to 3 plus I z square dz. Now, I'll simplify. See, along a line, if you take a line, so line is, suppose I take 0 to 3 plus I. This is a straight line passing to the origin. It's a straight line passing to the origin. So first z terms equal 0 comma 0. 0 comma 0 to 3 comma 1. So suddenly it's a line equations. First generalize means create a y form. Means z varies from 0 comma 0 to 3 comma 1. I say means varies from that. So make a line. You can make a line equation form y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1 form. So here x1 y1 should be equal to 0 comma 0, x2 y2 should be equal to 3 comma 1. So substituting value y minus 0 divided by x minus 0 is equal to 1 minus 0 divided by 3 minus 0. Suddenly we get y is equal to x by 3 or x is equal to 3y. So is given any form, you want to convert either converting x form or converting y form. So if we further we differentiate, z square should be equal to substituting z is x plus iy whole square. Again a plus b whole square formula, we get x square minus y square plus I times of 2x square. Again dz become dx plus I dy. So substituting integral of c z square dz. So it varies from 0 comma 0 to 3 comma 1, x square minus y square plus I times of 2x square dx plus I dy. Now I want to separate here real and imaginary terms. So integral from 0 comma 0 to 3 work as separating real terms. So is a real terms is x square minus y square dx minus 2xy dy. This is the real parts plus items of imaginary part. So integral from 0 comma 0 to 3 comma 1 2xy dx plus x square minus y square dy. Yeah, again I want to substitute either converting either x form or y form. So we have y equal to x by 3 or simply say x is equal to 3y. Now we shall convert all this integral into variable y, integrating y with respect to y varies from 0 to 1. That is say integral of c z square dz. So c z square integral y varies from 0 to 1. Replace all x by y means x is so replace x by 3y. So we get 9y square minus y square of 3 times of dy minus 2 times of 3y y into dy plus I times of y varies from 0 to 1 2 times of 3y y into 3 dy plus 9y square minus y square dy. Again I am simplifying y varies from 0 to 1 24y square minus 6y square dy plus I times of y varies from 0 to 1 18y square plus 8y square dy. Again I am simplifying this term 24 minus 6 should be equal to 18y square dy plus I times of 18y square plus 8y square. Totally we get 26. So 18 times of I am integrating with respect to y we get y cube by 3 plus I times of 26 again integrating with respect to y square we get y cube by 3 y varies from 0 to 1. That is we get totally we are substituting the values of y we get 6 plus 26 by 3 times of y. Thus integral of c z square dz should be equal to 3 plus 6 plus 26 by 3 item along a line or given path. This is the line. This is evaluation. The second problem and the same statement, the second statement, the line segment z equal to 0 and z equal to 3 means z equal to 0 means both x and y term is 0, simply say 0 comma 0. Z equal to 3 means 3 comma 0. So the varies from also z equal to 3 means 3 comma 0. X term is 0, y term is 0, x term is 3, y term is 0. Z equal to 3 plus I means 3 comma 1. This is the line. So means you are right. So integral of z square dz is equal to, this is a line from C1 to C2. The sum should be equal to C1 plus C2 form. So integral of z square dz is equal to integral of C1 z square dz plus integral of C2 z square dz. That is, we take a graph, that is, so here C1 from 0 to A, that is the term, then A to B is C2. If you take, means line, along a line C1, y is along x-axis, y term is 0. So derivative is also 0. So x varies from 0 to 3. So x varies. So x varies. So suddenly this z complex number in x form means z square become x square dx. So from here, from line, so AB, this is curve along a curve C2. So x equal to 3. We already run from 0 to 3. So x equal to 3. Dx is 0, derivative of that. Again, y varies from 0 to 1. So that is z square become replacing this form 3 plus I y whole square. 3 plus I y whole square. That is, the integral of z square dz should be equal to integral of x varies from 0 to 3 x square dx plus I times of. Here integral y varies from 0 to 1. So along a curve C1 x varies from 0 to 3. Along a curve C2 y varies from 0 to 1. We observe the graph. So integrating x square become x cube by 3. Integral run from 0 to 3 plus I times of. Again I am apply the formula a plus b whole square formula. Again integrating we get 9y minus y cube by 3 plus 3i y square. So replace y by 1 and minus 0. So simplify, we get 9 plus I times of 9 minus 1 by 3 plus 3i. So we get 9 minus 3 plus I times of 26 by 3. Again we get 6 plus 26 by 3i. So this is the evaluation value. So again we come to the second problems. So evaluate integral from minus 2 plus I to 5 plus 3i. 5 plus 3i z cube dz. Z cube dz. See, first make a path. The path of integration curve is consisting of. See, I draw an x-axis and y-axis. We get away from the x-axis, that is, make a line AB. AB. Now, the line segment AB is parallel to real axis from the point A. So, from the point A of minus 2 comma 1 and B of 5 comma 1. A of minus 2 comma 1 and point B of 5 comma 1. So line AB. So this line is y intercept. So y equal to 1. This is from the horizon to y. The y intercept y equal to 1. Length of y equal to 1. So y equal to 1. Derivative of y should be 0. X varies from minus 2 to 5. X varies from minus 2 to 5. So yeah, x varies from minus 2 to 5. Then if you come to the line curve BC, so straighten line BC parallel to imaginary axis. This is BC is parallel to imaginary axis. From what's the B coordinate 5 comma 1 and C coordinate 5 comma 3. That is on the line x is 3. So here x is 3. So derivative of x is become 0. That is y varies from 1 to 3. So that is, come to the problem. Integral of 2 plus I to 5 plus I z cube dz. So integrating along a line AB z cube dz plus integral of along line BC z cube dz is equal to, in the line AB is x varies. What is x varies? Minus 2 to 5. So I replace z by x plus I whole cube plus into dx plus y varies along a line BC, y varies from 1 to 3. So replace z by 3 plus I y whole cube, I times dy. So again simplifying and substituting this a plus b I whole cube formula, we get simply this constant up here. So x plus I whole raised to 4 by 4, x varies from minus 2 to 5. Again plus, again integrating this 3 plus I by whole raised to 4 by 4, y varies from 1 to 3. Suddenly we get 1 by 4 times of 131 plus high times of 408. Generally we come to the one more problems. If we come to the one more problems regarding the, if a curve is more than 2 or 3 curve, if you make a square from C1, C2, C3, suppose say. Evaluate integral of C mod z square dz, where C is a square, with what is this 0, 0, 1, 0, 1, 1 and 0, 1. First make a graph, with using the vertices. 0, 0 is origin, 0, 1 are first we take 1, 0 and 1, 1 and 0, 1. This is a square. So along a line, I call this is a line OA is a curve C1. Along a line AB, I call the curve C2. Along a line BD, curve C3. Along a line DO, a curve C4. So that is integral of C mod z square dz should be equal to I write integral of C1 mod z square dz plus integral of C2 mod z square dz plus integral of C3 mod z square dz plus integral of C4 mod z square dz. I call this equations. So mod, also I am simplifying. So you know the basic complex absolute values of z square certainly real number x square plus y square. So time these absolute values of z square become x square plus y square. What's the dz? Dx plus I dy. Now you come to the line along a line OA. We don't denote the curve C1. So along OA C1 we have along the x-axis y term is 0. So y equal to 0. Derivative of y is 0. So absolute values of z squares become y is 0. Suddenly we get x square dx. So along the line AB, I denote a curve C2 along a line ABC2. We have x equal to 1. So dx equal to 0. So mod z square dz become x equal to 1 means 1 plus y square. So dx is 0. So I times of d bar. So along a curve C2 become 1 plus phi square I d bar. Along a curve BD, I do not a curve C3, we have y is 1. So I will remove y is 1. Derivative of y should be 0. So absolute values of z square dz become x square, y is 1, x square plus 1 dx. So curve C. Again, along a curve DO, alright, denote a curve C4, we have here is a y-axis. That x should be 0, dx is 0. Absolute values of z square dz become x is 0, suddenly become y square I d bar. So we get all this. I'm substituting in equation form. In equation 1, so integral of c mod z square dz become integral of x varies from 0 to 1 x square dx plus I times of integral of y varies from 1 plus y square d bar and the curve AB line. Then the curve BD line become integral run from x to 1 to 0 x square plus 1 dx plus I times of integral y run from 1 to 0 y square d bar. So again I am simplifying and integrating. So first term become x cube by 3 0 to 1 plus I times of y plus y cube by 3 0 to 1 plus x cube by 3 plus x integral from 1 to 0 plus I times of y cube by 3. So totally substituting the values upper value minus lower value, we get 1 by 3 plus I times of 4 by 3 minus 4 by 3 minus I by 3. So totally simplifying, we get the value minus 1 plus I. That is integral of mod z square dz is equal to minus 1 plus I along a given path. So one more problems we take. So evaluate integral of conjugate of z square integral from 0 to 2 plus I conjugate of z square integral from 0 to 2 plus I along a line x equal to 2 along a line x. Now again I am simplifying conjugate of z. What's the conjugate of z? Should be x minus I1. So square that. So suddenly we get x square minus y square minus I times of 2y. 2xy we get. So if we simplify. Again dz equal to dx plus I d bar. So along the line x equal to 2y. Again differentiate dx become 2 times of d bar. So z varies from 0 to 2 plus I. So that is xy varies from 0 comma 0 to 2 comma 1. So z equal to means x and y term is 0 comma 0. 2 plus I means 2 comma 1 we get. That is y varies from 0 less than or equal to y less than or equal to 1. I am substituting integral of y varies from 0 to 1. I am replacing all that term. So replace x by 2y. So suddenly we get 4y square minus y square minus I times of 4y square of dx dy become 2 dy plus I dy. So that is we simplify integral from 0 to 1 3 minus 4i y square 2 plus I. Again I am simplifying. We simplify this y square I capacity. This is a constant. We take outside 5 times of 2 plus 2 minus I we get. So integral of 0 to 1 y square dy. So again simplifying 5 times of 2 minus I integrating y square with respect to y we get y cube by 3 varies from 0 to 1. That is 5 by 3 2 minus I. That is the values of given. Now we come to one more problems. So in form of a Euler forms, integral of c conjugate of z square around a circle mod z equal to 1, one problem. Secondly, mod z minus 1 equal to 1. So we know the meaning. Mod z equal to 1 means equation of a circle whose center is 0 comma 0 and the radius 1. So that is there. So if you take mod z equal to 1 is a circle with the center 0 comma 0 and the radius equal to 1. And the circle we have z equal to in Euler form z equal to r e power I theta. A radius r equal to 1. So suddenly r z equal to e power I theta. So if you differentiate with respect to z, we get dz high e power I theta d theta. So again, theta varies from 0 to 2 pi. Theta varies from 0 to 2 pi. So we come to the problem. Conjugate of z whole square should be equal to e power minus 2 times of I theta. So I come to the problem. Therefore, integral of c conjugate of z whole square dz become integral run from 0 to 2 pi. So e power minus 2 I theta I times of e power I theta d theta. Again this become I is constant. I take outside I times of integral of 0 to 2 pi e power minus 2 theta e power I theta. So suddenly become e power minus I theta d theta. I am starting integrating I times of e power minus I theta divided by minus I we get. So high y get cancelled, minus you get. So theta varies from 0 to 2 pi. So suddenly become minus times of e power minus 2 pi I minus 1. So minus of minus we get plus. We take minus 1 times of. I am substituting Euler formula e power 2 pi I cos 2 pi I plus I times of sine 2 pi or minus 2 pi. So sine of minus theta is minus sine theta. Generally we can write 1 minus cos 2 pi minus I times of sine 2 pi. So cos 2 pi is 1, sine 2 pi is 0. Suddenly 1 minus 1 we get equal to 0. So integral of this value should be equal to 0. Now we come to the second problem. The absolute values of z minus 1 equal to 1. This means this is a circle with the center 1 comma 0. Is the center with the center 1 comma 0 and the radius is 1. And the circle we have z minus 1. First z equal to r e power I theta. So r power is r radius, r is 1. Simply say e power I theta. So z equal to e power I theta plus 1. If we take 1 this side become z equal to e power I theta plus 1. So differentiate we get I times of e power I theta d theta. So absolute values of z square become, so mod z square whole square equal to 1 plus e power I theta minus I theta plus e power minus 2 I theta. So therefore integral of c absolute value conjugate of z whole square dz become, so theta varies from 0 to 2 pi. So 1 plus 2 I e power minus I theta plus e power minus 2 I theta of I e power I theta. Again I am simplifying, open this simplifying. So integral of 0 to 2 pi I e power I theta plus 2I plus I e power minus I theta d theta. Again separating, applying the values 0 to 2 pi. So it become e power I theta plus 2I theta minus e power minus I theta. So simplifying, totally we get cos 2 pi plus I sin 2 pi plus 4I minus cos 2 pi minus I sin 2 pi. Totally we get, simplifying, 4 pi I. So one more, if we come to the problem, evaluate integral from 0 comma 3 to 2 comma 4 to y plus x square dx plus 3x minus y dy along the parabola x equal to 2t and y equal to t square plus 3, y equal to t square plus 3. First one. Second one, the straight line from 0 comma 3 to 2 comma 4. The first, if x varies from 0 to 2 and x equal to 0 and 2t equal to 0, therefore t equal to 0, and x equal to 2 and 2t should be equal to 2 or t equal to 1, means that is t varies from 0 to 1. So again the given problem 0 comma 3 to 2 comma 4, the integral from 0 comma 3 to 2 comma 4 to y plus x square dx plus 3x minus y dy. So substituting, so I convert all x in terms of t, and so we get integral t varies from 0 to 1, 2 times of t square plus 3 plus 4t square of 2 dt plus 3 of 2t minus t square plus 3 times of 2 dt. So totally we get, open this integral run from t varies from 0 to 1, 2 of t square plus 3 plus 4t square of 2 times of that, again 3 times of that, you get, simplifying we get integral run from 0 to 1 of 2 of 6t square plus 6 plus 6t minus t square minus 3 of 2t dt. So simplifying, integral run from 0 to 1, 24t square minus 2t cube minus 6t plus 12 dt. Again start integrating, 24 integral of t square become t t cube by 3 minus 2 t raised to 4 by 4 again minus 6 t square by 2 plus 12t. So replace t by 1, then we get the value should be equal to 8 minus 1 by 2 minus 3 plus 12. Suddenly we get 33 by 2. Now one more problem in form of a line joining. The same is given. The equation of a line joining 0, 3 to 2, 4 is given by. So first make a line equations using the point 0, 3 and 2, 4. Make a line by using the point. So certainly you use a formula y minus y1 divided by x minus x1, y2 equal to y2 minus y1 divided by x2 minus x1 formula. So suddenly I am substituting the value, we get y minus 3 divided by x minus 0 equal to 4 minus 3 divided by 2 minus 0. Suddenly we get x is equal to 2y minus 6. So suddenly we get x equal to 2y minus 6. Hence, if we differentiate, we get dx is equal to 2 times of dy. Also, y varies from 3 to 4. So all substitute replace x by 2y minus 6 times. So replace x by 2y minus 6. So simplify, y varies from 3 to 4, 2y plus 2y minus 6 whole square of 2 times of dy plus 3 times of 2y minus 6 minus y dy. So come to the problem, I am replacing x by 2y minus 6. That is the problem. So y varies from 3 to 4. That is we get 4y square minus 22y plus 36 times of 2 plus 5y minus 18 of dy. Suddenly we get y varies from 3 to 4, 8y square minus 39y plus 54. Suddenly we simplify, integrating y, we get 8 times of y cube by 3 minus 39 times of y square by 2 plus 54 times of y. So substituting, we get the value should be equal to 97 by 6. So this is the problems, but we are taking very few problems regarding, but I applying the basic properties of a line integral, path integral, we solve some few problems.